synchronized. Hey makers, and welcome to another episode. Now you might be asking yourself what we are doing here. Well, basically we are going to make a box that will hold these three power supplies for my DIY 3D printed CNC machine. Now you might be asking yourself why I'm making this. If you watched the previous video, you will know that I'm actually using 220 AC Dremel for my router. Well, changing plans, we are going to use this from now on. This is 12 to 36 volts, 80 watt DC motor. You generally found it in small CNC machines like the 3080, and I have a pretty good reason why I'm doing this downgrade. Actually, this is a downgrade, and I actually had to invest more money on the CNC, which is something that I didn't want to have to do, but hey, you gotta do what you gotta do. So in this video, we are going to assemble this box. This is 3mm MDF, and as you can see, I really like how it turns out. It's clean. There are some holes that I did not design because I have a method to do so, and probably this method will be to your liking. So here's the idea. The motor needs 36 volts to work at its maximum, something like that. Well, I had a look at this on eBay and AliExpress. There are a lot of variation. They say it can work from 12 to 14 volts. Some can say it works from 12 to 36 volts. Well, I'm not sure, so I'm only going to feed 36 volts. And I actually bought a controller that sends PWM signals from a power supply, which will be this one. And I'm gonna build a small tachymeter using an Arduino to check the RPM, and that will be a subject for another video. So if you want to see that, make sure to subscribe for the upcoming videos, and I will be putting everything about my CNC as an open source when I'm finally done with it, because I want to push everything online when I know it works and works great, so you will not spend money making something useless. Anyway, so there are some holes that I did not drill. So basically this is the bottom plane, and the idea is I'm gonna fix these here somehow with easy access to the wires. Then these will be here, this will be on the top, and this will be on the side. And on the front panel, which is this one right here, I'm going to have the socket for AC socket. I'm gonna have an on-off switch, and this will be an external fuse, because you never know when the motor will stop working. Maybe I made the depth of cut too much, or the material that I'm doing melted and stopped the motor from rotating. It's going to consume more current, and I'm afraid it's going to burn itself down, and I don't want that to happen. So I'm gonna have a fuse that will be connected in series to the motor, which will prevent any overcurrent from basically burning my motor. And because this is gonna be on the outside, it's easy to just open this up and change the fuse whenever I blow it. And I have hunches that I'm actually going to blow a lot of fuses. Anyway, so let's start with assembling these power supplies. Now, at first I wanted to measure everything and make everything in CAD, but I was not able to find a proper model for these power supplies. And as you can see, these are very big power supplies. Now, the original plans was to use 12 volts 5 amps, which is the same as the small power supplies. As you can see, the difference is huge, but the seller did not have any 12 5 amps, so instead I bought 12 10 amps, which I think it's gonna be good because I bought these with the same price as these, so that's the win for me. Anyway, so we have 3 of these that I need to stick in here, because the last thing you want is plain power supplies in your box. So the idea is simple. I have this plastic thingy right here, and this will be my template. So I'm gonna hold this like this, then I am going to drill holes using my hot soldering iron, and this will be my template. Then I'm going to transfer this into the wood and cut it using a Dremel, and that way I'm gonna have a perfectly spaced holes that I can just fit M3 screws in it without having any problem. Is that genius or what? So let's get this started. Okay, now it's time for the cable management. So basically what's gonna happen is I will have the phase in series and the neutral in series, and then I'm going to wire them here. So let's do that. So this will be fitted like this. Then I need to solder some wires from here, and for the wires I'm gonna use some wires that I got from an old ATX power supplies. They are pretty handy for this kind of applications. So we have minus to plus, then minus to plus. If we power this, here we should have 12 volts. From this plus to this minus we should have 24 volts, and from this plus to this minus we should have 36 volts. Let's give it a try. Nice. 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 I think it turned out quite well. It looks like DIY, TN, inventors, CNC. Oh yeah, oh yeah. Yeah, yeah. What a beast. Put this in here. Turn it on. Nice. And what an airflow. What an airflow. That's a lot of air coming out. That's a very strong fan. I mean, this is fan for emergencies, like when you're cutting something for 10 hours, 20 hours. That's when you use a fan. Probably you'll not reach 20 hours, but hey, 10 hours is plenty. Plus, this power supply is strong enough